Make sure this is understood by you and clearly indicated in your notes. Centripetal force causes all circular motion. So that should be already indicated. When I was putting this around in a uniform circular motion where the acceleration was, where the velocity was constant, it is, does it show me? I'm in the dark even? Alright, as this goes around like this, in a uniform way, you realize that centripetal force is causing the circular motion. But I want you to know that when I go like this and let it slow down, so like I give it a whip and then it slows down, I give it a whip and then it slows down. It is no longer uniform circular motion, but I want you to know that centripetal force is still causing the circular motion. So that's why I was indicating here, centripetal force causes all circular motion, whether it's uniform or not. So make sure that is clear to your understanding. All right, we didn't get this far. We need a formula for centripetal force. I'm sure you rest ill at ease all weekend wondering about this. So, force centripetal is mv squared over r. Mass, velocity squared over r. Need to write it down. It's a big player now. Force, velocity squared, force centripetal is mass, velocity squared over r. Alright. Not so bad of a formula, is it?
No.
Yeah. Alright, so, and I know you were wondering all weekend as well, what are the units for force centripetal? Alright, force centripetal, can you look at the formula and doodle on your paper or in your mind and come up with a unit? Remember what mass is, remember what velocity is. We squared it, and remember what our radius is, just the length. So put all those units together and see if you can come up with the unit for force centripetal.
It's been raining all day.
Little bit of snow in the rain, but it melts as soon as it hits.
No, I want to go home.
I think it's a rain event, I'm sorry.
I like rain better than snow.
Well,
Oh,
I
it's
like
so
school
beautiful.
off whenever.
I'd rather go now than in the summer, though.
Yeah, I like summer.
All right.
And I don't like cold.
What are you coming up with? I'll write on the board and erase it. What are you getting for mass? Can you help us, Aaron? What's mass measured
Would
in?
it be kilograms?
All right. And then Aaron, Brendan, what's velocity? And then square it.
I couldn't remember that.
Velocity.
Meters per second squared.
Right, meters per
That's like
second.
acceleration.
No, it's not.
See, meters per second. And then this is what squares it. All right. And then what about radius, Morgan?
Centimeters?
Well, since we work with meters up here,
Just meters.
all right. Now, mathematicians, I need you to simplify that. You wonder why we take these expressions in algebra and simplify them all the time? For this very moment. So go ahead.
Ends cross out.
And you have to figure that out. So this means kilograms meters squared over,
Hi, John.
oh, welcome. All right, you can sit over here. This will be your seat, but Molly's taping for me since you weren't here to tape for me. All right. All right, we're just taking notes in our comp books, and I'll move my stuff. You can sit. Yeah, you probably see better there. So I'll leave my stuff here. Thank you, Abby. The beginning of class is on a video for you, Jonathan. So, all right. Do you see where I got that? The S goes down in the denominator. Both the M and the S are squared because of the formula. So, Morgan, your question can now be answered clearly. What happens?
Well, the M on the bottom can cross out, and it will cross one of them out on the top.
Right, so we end up with kilograms, meters per second squared. All right, does that look familiar? We've seen this guy before, and he has a name. Kilogram meters per second squared. What is that? Does it sound familiar? kilogram meters per second squared is our old friend, the Newton. So, you all right?
Yeah, just can't catch.
Pardon, all that is just a Newton. Does it not surprise you that force is centripetal is a Newton? Force, centripetal is a force. So what's the unit for force? Newton. So it turned out to be just a Newton. So force, the units are a Newton. Let me erase the chalk. I wrote it on the transparency as well. But I didn't want to show it up until we talked about it. Alright. Let's continue then. Have you got that? Let me peek at it. You got that? That the unit is a Newton? Alright. Got your Newtons? Okay. Alright. The unit is a Newton. So, I'm repeating the formula again. Force centripetal equals mv squared over r. And we know from our friend Newton, Mr. Newton, Sir Isaac, that force, Newton's laws, force equals ma. So that's true as well as for force centripetal. So I'll put in a little c for centripetal and a little c for acceleration centripetal. So what can I do mathematically when I have two things equal to the same thing? I can set them equal to each other. So I'm replacing force centripetal with ma because force equals ma, and I set those two equal. All right, mathematicians, simplify. And what remains? What can I do, Annabella, mathematically to that last statement to simplify it?
Would you cancel out the m's?
Right. And I think that's about it, don't you?
Yes.
So we came up with a second formula. So here was our first one. And now acceleration centripetal is just v squared over r. So once you got those down, we'll do a couple problems. Calculators out, and we'll see what happens with those. All right, this one I don't, yeah. Oh, I thought your hand was up.
Oh, no, sorry. I was
Being dramatic. All right. Here's the transparency. Here's the first one. All right. A lot of that's review from Friday, John. If that helps. All right, I don't have a transparency for this one, so I'll just write it on the overhead. All right. Draw a smart car or some sort of car. Actually, it's a toy smart car because it's only 151 grams. It's going around in a circle. I need you to be quiet, please. I want you to take the car and assign it 151 grams and move it around in a circle. It won't fit on there. Sorry, I wrote it too high, but you can see 151 grams. Going in a circle, I'll move the radius so you can see it. The radius of the circle is 1.1 meters. It's going at a constant velocity, and that velocity is 2.1 meters per second. Oh, that didn't show up. And I'm going to ask you to find force centripetal. Alright, so use the formula, plug and chug.